Hello everyone, let's start speaking about Kafka connector, and today we will learn how to configure and use Kafka connectors with different types of databases and data storage. So let's start with a Kafka topic. We have learned before that there are two pieces of software. Some of them is called the producer, that is used to send messages to a topic, and another is called the consumer, that is used to read or receive messages from this topic. But what if we wanted to integrate this topic with another data storage? Uh, like sending data from the data storage into the topic or from the topic to data storage, then we need another components called connectors, and we have two types of connector. The first is called source connector, and for source connector, each record, each row in our data storage will be sent as a message into Kafka topic. And this other type is called sync connector, and for sync connector, each topic, each message within a topic, within this topic, will be stored in the data storage. Both the sync and the source connectors are automatically working. Just you configure them and they automatically work. Um, and they are a part of Confluent Cloud Kafka. So just you need to configure them, and there is no additional code to write for them. So let's start first by setting our connectors for MySQL. So to start this, let's check that MySQL is still deployed over Kubernetes by checking Kubernetes control get services. And you should see two services, one of them for MySQL and the other for Redis. And for MySQL, we are interested in the IP, which is look like this, will be different than yours. So just work in your version of MySQL, and also the port number, which is 3306, which is this. We will need those two to in the configuration of our connectors, so that the connector can be connected to this MySQL. So right now, let's go to our Confluent Cloud and choose our cluster, whatever its name is. And you will see that there are like a tab called data integration, and in data integration there is a connector, and we can add a new connector. And there is a lot of types of connectors here, you can see. Each of this connector may be sync or source, and is specified to a certain type of data storage, and there are a lot of them. So just go and search for MySQL, and by searching for MySQL, there are the optional here, which is MySQL sync or source. So this is it's starting with a source data storage. Okay, this is the source data storage, and then start with to configure this. So that is the name of the connector. Leave it or change whatever you want. After this, you have to enter the credential for Kafka cluster, and will choose that it will be through Kafka API key, and this API key is given to you, and you used it in the previous tutorial. So just reuse the same API key and API secret. If not, just generate a new one. You can generate a new one by clicking on this link. So for me, That is my credential here. Okay, just a second. Yeah, this is the API key, which is work like a username. And here is my API secret. Right now. After setting the credential for Kafka, there is another configuration like the prefix of table names. Like if I write my DB, this will be the prefix that will be concatenated to each table name to generate the topic name. So if in my database I have a table called test, uh, each record in this test table will be converted and sent into topic called mydb test. So just this prefix will be concatenated to the table name to produce the topic name. Okay, what else? As a credential for my database, and to add enter this credential, I need the IP address. I just copied it before, so let's paste it here. And for the port number, which is 306, and the username and the password for MySQL database, you can find them in the YAML file that used to deploy this MySQL in Kubernetes, and the username was user and the password was the same like your course ID, like this, and the database name was mydb, and the security SSL mode will be preferred. Here I just set the credential for MySQL. Now let's continue our configuration. And in this configuration, like the table names, I can choose a list of table names from this database, from this schema, like test. If you remember before, we have using this script code is called sc1.sql to generate a table in MyDB schema, and this table is called test, and this is a configuration of this table, like the fields of this table, and inserted some data on it. So let's drop this table if it exists. So just here drop table test. Okay, there is no table like this, so it's okay. It's no table. Then let's generate our table. Let's go. First, let's change the directory. Like if you are in the home directory, we'll find the directory for our repo. So for our repo, there is this folder, and within this folder you find GKE, and within GKE you find sc1.sql. So just we want to run this file right now, so it will be like this, sc1.sql. Now it is created, we can check about it like by selecting all record in it. Like select the asterisk from table from test, and here is the record. So now let's return back and see what is the table name. I just need to work with this table was called test, so just entering test, no more. And there must be two columns for this table. One of them contains the date in which this record is created, is called timestamp, and the other is the primary key, which is the incrementing column name. So both of them can be found here. The timestamp one is called modified, and the primary key is ID. So I go here and say modified, and for incrementing column name, let's call it ID. So it's okay. Now I configure all of the important things. Let's go to pool interval. Pool interval is how often this connector will check MySQL for new records. So let it be 1/10 of the second. Another thing, what is the format for the value that will be converted and produced into this topic. We have four formats. This was a question asked to you, so we have four of them, and each of them has its properties or advantage, but I'll use a Vero. And also how many tasks for this connector, just one task. Now it is created, it is configured. Let's click next. Here is a summary for this connector with the price per hour or per gigabyte. You can see it, and also like a JSON object contain all the configuration right here. So let's launch this connector. So connector created, but it is not running. It is in the initiation process first. It may take like a minute. If you enter here, you see this messages that this may take a few minutes for the connector to start up. But let's see. Let's recap what will happen now. What will happen is that we have just one table here in our database. Like if I go and run show tables, you find there is just one table. It's called test. So this table will be converted into a topic with its name will be has a prefix of mydb, so it will call the mydb test. And when this connector works, each record in this table will be converted into a message in this Kafka topic, which we will call mydb test. So just we will wait some minutes for this connector to run. Probably it run fast. It is now running. Okay. If we enter to it, we find some statistic like throughput, how many messages per second, and the production, how many bytes per second this connector are producing. And how the tasks here is just one and all of them are running. There is no failed or both ones of them. So still none is the messages is consumed right now. So let's go to topics. We find there is a topic. It's called MyDB test and have 9 bytes per second. And if we enter this topic, yeah, that is like the number uh, of uh, of messages or bytes per second for this topic it changes with time. So if we go to like messages, and go to a previous one like message 0 partition 0, you find these messages which has the value of each record in a binary file. So this bizarre symbols are because only it's in a binary format. So if you put it like this, and just uh, run the same script again, and if you remember, this script will delete the table and create a new one and insert these values into this table again. So now you find that a new messages has been produced to our topic. So that's okay. Now if we wanted to read these messages on our local machine, what we shall do, you will find in the same repo and a third folder. It's called connectors, and within connectors there is MySQL, and in the MySQL you find 4 files like this, and here we just wanted to consumer MySQL.py, and this is a code that will try to connect to this topic, read from it, and deserialize each message in it. So let's go into this file and try to understand what is written in these files and how to use them. So let's go to connectors and MySQL, and there was ours, and start by opening this. So first, my credential is written in a file called credential.json, and this will be read into data, and from it the bootstrap will be obtained, and the API key and the API secret. So where is this credential.json? It's here, it's this file. Just you have to fill this with the bootstrap servers for Kafka, Confluent Cloud, and the API key for your cluster, and the API secret for your cluster. Just fill them here and save this file. For me, I have my fill file. Let me copy and paste it. So I replace it with another one filled with my credential, and now uh, the credential for Kafka topic is granted here. So just uh, I can create a consumer, but this consumer will consume messages in Avro format. So how this Avro can be deserialized, as a binary format of Avro can be serialized. It will be serialized using the schema for this message, and to get this schema I have to go back into close it, no, it's here, to Config Cloud and to topic, and you'll find that the schema is set. The schema is obtained from the table description in MySQL, and it is written like this. It has it's called test, and it has 5 fields. One of them is the name, its ID, and long. The other is name and has either be null, or which means it's optional, or it can be a string, and it can configure like a GUI like here, the graphical user interface like here, or just you can click evolve to change it like a JSON. Just we want to copy this and pull this schema in this file which is called schema Avro schema. So let's open it with Notepad and paste it. As you can see, that is the connect name and also the fields, which is ID of type long. Name has a default of null, and it can be null or string. And also there is another what's called email, and the email has its default is null, and it can be null or string. Also all of these, and also there is modified, which is timestamp like this. All you need is to delete this logical type, because Python is not uh, uh, Python will give you an error because Python is not compatible with this logical type. So there's nothing will happen, just delete this line and save the file. So let's return to our code again. Now Avro will use this schema file we have just filled to decode each message will be read from Kafka. And here is a code that will be used by our Python code to read the schema. And for each message, this function will be used to decode the message and return it in a dictionary or a JSON format. So how this is done by reading it as a byte, and Kafka conflict connector will add like schema ID in the first 5 bytes. So just we'll skip this 5 bytes, and then starting to convert uh, the remaining bytes into a dictionary using the schema reader here, which is the same here, and this will be like a dictionary. This is called deserializing, which means that we have a binary and we convert it into the original format. So that is a deserializer function for the key. And when we are configuring our consumer, just we are giving it the bootstrap and the user name, which is the API key, and the password, which is the API secret, and also group ID. If we left it as none, that means that for each run of our code, it will be considered in a different group ID. If we just specify a certain group ID, that means that this the message consumed with it won't be consumed again. So let's return back here with none and see what is else. This is value serializer, and for the value serializer we will run the decode function, which is this function for each message to convert it to the dictionary. And for key deserializer, just we are converting it from to a string, a JSON string. If it is not empty, if it is none, just an empty string. So here's we are configuring how we are configuring our consumer. Then we will subscribe to MyDB test, that is the name of the topic, and here is a code that automatically generate consume a message, and of course when for each message consume these two functions, the deserializer for the value and the key is called, and the result will be printed like printing the message partition and message key like here, and message value also, and wait a little and then continue to consume others and others. So that is the code we need. All we need is to set the credential JSON to our credential, to our Kafka credential, and schema to the schema for this topic. So after this, let's go and dire here and go to MySQL, there again, and here is our file, which is consumer MySQL. Let's run it. And here is each message is deserialized from Avro to JSON or to dictionary, and this dictionary or JSON is printed like here. To check again, let's go to our Google Cloud and run this again, and you'll see that a new message will be start to be consumed and printed here. How this happen? This happen because each record is stored here is consumed by the connector and pushed into the topic, and this topic will be consumed here by my consumer and printed to the screen.